Or it can be an actual book hook. But it is a requirement, so it'll be 4 points.
Well, we're busy.
You can't wait 9 minutes. Okay, I'm not going to check it now. You are supposed to have a book with you. All right, I'm not going to take we need your book to get the problems out of it. We're going to do right here, but I'm not taking points right now for your book. But everybody does have to have a book. So, remember the whole, well, I'm not going to say it on video. Some of you know how to get a book online. Take care of that, or get a hard book. I don't care, but we gotta have a book. Okay. So first thing we're going to do, we're back in our note packet, and if we start up right where we left off on the back of page 7. Back of page 7 is where we left off in our notes, not our practice tests. The practice tests now you can store away, keep for study later. Right now we're on the back of page 7, and we're down in there where it says 1-1, page 81. And it refers us first to problem 12. So actually it's page 82.
In the book?
In the book. Page 82 in the book. The back of page 7 in the note packet.
Page 82
in the book, page 82, just like it says there in your notes. Well, it says page 81, but you have to turn to get to number 12. Number 12 says, according to the numerical model, what has been the trend in males joining the workforce since 1954? Now, a numerical model or a mathematical model can be a picture, so it can be a graph, it can be a list of numbers, it can be a table, it can be anything. So when we say a mathematical model, that can be any way of representing the numbers. So in this particular problem, it's a table of values. So it says, look at this table, and what has been the trend in females joining, oh wait, I'm on number 12. What has been the trend in males joining the workforce since 1954? So look at the male column. What's happening to those numbers? What's the trend? They're decreasing. And that's the answer to the question. It says, what has been the trend? So the trend is it's decreasing. Don't make it any harder than that. You're just supposed to observe what's happening. Then number B says, in what 5-year interval did the percentage of men change the most? So you're just going to look at the information's in 5-year intervals. So for example, from 54 to 59, it went down, what, 0.8? And then the next time it went down, what, 1.4? I'm trying to subtract in my head. I hope I'm doing it right. So which interval does it look like it had the biggest change? Can you tell? We're doing men.
2004.
We're doing number 12. Number 12 says men.
19.
Where do we look like we have the biggest gap?
69 to 74.
69 to 74? Yeah. How much did it go down there? Help me with that subtraction. Is that 3.2?
Yeah.
Okay. Okay, that's 3.2. Does it ever go down more than that?
No.
What about 79 to 84?
Where's that at? That's 2.3.
That's 3.3, isn't it?
Mm-hmm.
Yeah, so that's more, isn't it? A little bit more. So I think the biggest gap is actually 79 to 84.
I don't see that.
Although the one you said was close to that. But I think it's bigger on 79 to 84. For most of you, your exposure to mathematics is going to be through what you read and see and the data people give you. So it's really important that you can look at a set of data and make your own conclusions based on it. Okay? Someday I'll tell you the story about how a very large public school system in this area really duped people by the way they rigged their study and their statistics, but I don't have time to do it today, but someday I will. You have to be careful when you're working with numbers. You have to be smart when you look at it. One more problem, then we're out of time. Number 20. A bakery sells a 9x13 cake and an 8-inch diameter cake. So you guys have all made cakes at home, or your mom makes cakes. So you know this is your rectangular cake, you know, it's in that pan. And then an 8-inch diameter layer cake. Isn't that what it says? Round cake is twice the height of the rectangular cake. Yeah, so this is your round cake. And it's an 8-inch diameter. So you walk into the bakery and you're gonna buy one of these cakes, and they're the same price. So assuming you don't have a preference for one shape over the other, what would you like to know? If they're the same price, what would you like to know?
How much cake do you get with both?
How much cake do you get with each one? Because you want to, if you're paying the same amount of money, you want to get the most cake for that money, right? Does anybody know what word we give that? We don't know how much cake we have. What word do we give that? What?
Cake per square.
Well, okay, so volume. We want volume, and it would be cubic inch. So we want the volume of these two cakes. Now, this is a rectangular cake. Anybody know how to find the volume? Length times width times height. Okay? So length times width times height. Now we know we're 13 by 9. Do we know how tall this cake is? No. In fact, we know nothing about how tall either one of them are, except this one is twice as tall as that one. This one's like 2 layers. So let's just let the height be an inch. Then for this one, the height is going to be 2 inches, right? Double that.
Mm-hmm.
If you don't like 1 and 2, you can use 2 and 4. You can use 6 and 12. I don't care what you use, just so that height is half of this one. All right, what's 13 times 9? 717 cubic inches. So if you buy the rectangular cake, you are going to get 117 cubic inches of cake. That's how much cake you're going to get. All right, well, what if we buy the round cake, the layer cake? Don't you have your birthday with candles and stuff on it? What if we buy that?
Where are you going to eat the
What shape is that? Well, it's a circle if I look at it like this, but what if it's sitting there on the plate? It's a what? It's a cylinder. Anybody remember the formula for the volume of a cylinder? Okay, somebody said 1/3 something. That would be for a cone. Yep. It's pi r squared h. Pi r squared h.
Oh, that's, yeah, I knew it.
So pi, now be careful, 8 is the diameter, so the radius would be 4, so this would be 16. And we said our height was going to be 2. Now remember, they didn't give us a height. We get to make it up as long as this one is twice that one. You can use whatever height you want. All right, so that's 32 pi. Who's got a calculator out?
100.5.
That's 100.5 cubic inches. So if you are not caring about what the cake looks like, if you are interested in just getting the most for your money, you're going to choose the
circle.
Aren't you going to pick the rectangle?
Yeah.
Oh, yeah, you're right.
Isn't that more than the square was? Yes. All right, well, we're going to continue this discussion next time. Again, this is your very last